It's called the somatic mutation theory, otherwise known as the oncogene theory. And here's basically the outline of the theory. A cell has a cell membrane, and it has a cytoplasm, which is the watery part, which has stuff in it like mitochondria and ribosomes and things. And then it has a nucleus, which houses the DNA, which is in the form of chromosomes, which contain genes, which are like pieces of the chromosomes. Each gene codes for a protein or makes possible the formation of the protein. And the proteins are the action molecules in living systems. So the oncogene theory is very simple. In one of the somatic chromosomes, we have 46 chromosomes, 44 of them are somatic, and one is an X, and the other is a Y, or two are X's in the case of females. So we're not talking about the X or the Y chromosome, we're talking about the other ones. One of them has a change in one of the genes, and that gene creates a protein which is abnormal, and that causes the person to get cancer. So the entire research establishment, the entire biotech industry, the entire testing of cancer, really since that time has been finding these defective genes, correlating them with cancer, and then trying to do something about them so that they can do something about the cancer. The unfortunate reality is, after almost 50 years, something like 2 to 5% of cancer therapy has anything to do with oncogenes. So in spite of, like I say, hundreds of billions or trillions of dollars looking for oncogenes, they can't, with rare exception, they can't find any that have any relevance. So they just use the same old surgery, radiation, and chemotherapy, which has nothing to do with oncogenes. It's just saying, there's the tumor, I'm going to cut it out or burn it out or poison the cells so they don't divide. And it doesn't have anything to do with oncogenes. But here's the real problem with that theory. It turns out, in my opinion, and I have good reason to say this, cancer not only has nothing to do with genes, mutated or not, it has nothing to do with chromosomes, abnormal or not, and it has nothing even to do with the nucleus. Now, why do I say that? For a very simple reason. And this is in some ways the key, although I can even expand on this further later if we want. If you imagine a cell in your body, let's say in the breast or in the prostate, it has this membrane, and then it has the watery part, and then it has the nucleus. So it has two different compartments in the cell. If you do an experiment, you can take two normal cells, you can transfer the nuclei from one normal cell into the other and vice versa. You can see what happens, and both cells will create normal progeny, right? So that's very simple. Then you can take the nucleus from a cancer cell, where these oncogenes are, and you put that into a healthy cytoplasm, in other words, the cytoplasm of a cell from normal tissue, and interestingly, the progeny are normal. And then you can do the opposite. You can take a healthy nucleus and put it into the cytoplasm from a cancer cell, and lo and behold, the progeny are cancer. And I have the references for this in my book. It's been done by a number of different scientists in a number of different labs. It's very repeatable and predictable. And what it tells you is the location of the defect in cancer is in the cytoplasm, not in the nucleus. So if it's not in the nucleus, it can't be in the chromosomes. And if it's not in the nucleus, it can't be in the genes. So these somatic mutations that they see are not the cause of anything. They're simply a product of a diseased cytoplasm. And what's interesting when you read these actual papers, that what I would call delusion behind this, in other words, it must be these mutations that cause cancer, is so deep that these scientists actually propose, without any evidence at all, that there must be something in a normal cytoplasm that can actually heal mutations, which is completely bizarre because they have no evidence to suggest that, but they just can't bring themselves to say, the problem is in the cytoplasm, we better start understanding how a sick cytoplasm causes this disease we call cancer. And you know, in my book, I liken this, to an analogy to help people understand what's going on here. It's very much like the old story of, you're walking along and you see somebody under a street light looking for something. And you come up to the man or woman and you say, "What are you looking for?" And he says, "My keys." Oh, so you say, "I'll help you for a minute." So you start looking for his keys or her keys. And after a while, you can't find them. And you say, "Well, where did you lose your keys?" And they say, "Over there in the bushes." And you say, "Well, why are you looking under the street light?" And he says, "Because the light's better." And I will admit, it's easier in a certain way, to look in the nucleus and look at the genes. We have a lot of technology for mapping genes and figuring out what genes are what. But the problem is, if you lost your keys in the cytoplasm, you can look forever and you won't find them. And somehow that simple lesson is lost on the entirety of the oncological community, much to the detriment of the people and the patients.